So welcome everyone to our masterclass on overcoming Kubernetes debugging challenges using Garden and Rookout. I'm here today with Yun, the CEO of Garden, and Oded, the head of product at Rookout. So before we get started, I'd like to remind everyone that if you have any questions during this event, please feel free to write it in the question box and we will 100% get to them at the end. So we're not ignoring you, we will get to them. And so without further ado, I'll hand it over to Yun. Take it away.
Hi, my name is Yon. I'm the CEO and one of the founders of Garden. So I'm CEO, I'm an engineer by trade, so I'll be doing a bit of a demo and talking a little bit about how Garden works. And I've also been trying out Rookout over the last few weeks and really enjoying that experience. And I think it's a great combination with what we do at Garden. Yeah, I'll hand it over to Oded, and then I'll come back later to talk a little bit more about Garden, show you how it works.
Cool. My name is Oded. I lead the product team at Rookout. And one of our favorite problems to talk about, and one of our least favorite problems to handle ourselves, is solving customer issues that happen in production or in the live environments, because these are usually the issues that impact business the most. You don't want to lose a POC or a deal due to an unsatisfied customer, and you don't want to be measured on SLA because that always feels like a losing battle. So let me ask you guys a question, either you or your teams. First of all, ask yourselves, how often do you think you and your team spend on solving customer issues that were escalated to the R&D team from the support team? And more importantly, and Maor is going to pop up poll in a minute, so we can all answer and discuss the responses. Where is most of the time spent? What is the hardest thing about solving a customer's issue? So Maor, can you pop up the poll? Okay. And I will be honest, we have a guess of what the answer is going to be. And yes, so far it seems that you guys are facing the same challenges that we have. We see that we have a couple of answers about just being notified about the issue, and almost half of you said that finding the root cause is the biggest problem, but a vast majority has responded that being able to reproduce the issue is a big challenge. And being able to reproduce the issue has always been a big challenge. And we believe it becomes an even bigger challenge in the world of Kubernetes debugging, because in the world of microservices in general and Kubernetes specifically, it's harder to create a faithful representation of the live environment on your own desktop, harder to the extent that it's sometimes impossible. And cannot reproduce is a classic problem of software engineering. And sometimes I just ask myself, how is cannot reproduce still an issue in today's ecosystem? And when you're trying to debug microservices, cannot reproduce is a problem because there are just so many moving parts, so many things can be different and differ between the customer environment, the test environment, your local desktop. The configuration is never the same. The network conditions are never the same. Customers have specific data sets that impact and cause a bug to reproduce. The code versions keep shifting, and there isn't just one version of the code. Every microservice has its own development cycle. Every team pushes at another time. The deployment, the Kubernetes deployment itself varies and is hard to reproduce on your desktop. And these are problems that both Garden and Rookout try to address, and very happily we've just found that we actually address them even better when the tools are used together. But before I get to that, just a word and a couple of thoughts about how most of our customers told us that they try to debug and reproduce Kubernetes issues today. And some of them mentioned that they just use the Kubernetes command lines, which are just mostly about getting a health check about the pods or restarting the pods. But you don't get way beyond that with just the command line. If you can, if you're lucky, if you have a way to deploy your own microservice or even a small representation of the environment on your desktop, you are lucky. Most of our customers report that they were unable to do that, and in many environments, connecting to a remote environment, what we used to call SSH debugging, connecting to a remote server, is just not something that you can do in the world of microservices and Kubernetes. There isn't a server for you to attach to. The pods keep spinning up and down. The architecture is very complex, and most of us have learned to fall back on a couple of practices, either logging and tracing, which means that you will spend a lot of your time writing code that prints logs that if anything goes wrong, you will need it. And that means that when a new problem comes along, you will need to add a log line and push it and wait for it to be pushed and wait for the issue to be reproduced again before you can actually get a log of what happened. And falling back after that, we fall back to just pushing to CI and praying, hoping that the one thing we changed is the one thing that fixes the problems. And we know that that is not remotely often the case, which is where Rookout and Garden come in. Rookout is an application that lets you debug basically anywhere and anything. You can debug an application that runs on your desktop, and you can debug a very complex microservices deployment running in the cloud, running in your customer's environment. We use a technology called non-breaking breakpoints. You may have heard of similar technologies called log points or trace points, but they are basically tools that let you set a breakpoint at a line of code and get the data without stopping your application, because in a live dynamic cloud environment, you cannot stop the code. So that's Rookout. We're going to see it as part of the demo in a couple of minutes, and let me hand it to Jon, who will chat about Garden.
Right. Yeah, I think it's actually been a really interesting project working on this webinar, because what Garden and Rookout do is so complementary, but kind of in the same general problem space. So what Garden allows people to do is to fully define all the relationships between every part of their system, and with the aim of being able to, for every developer or even a CI pipeline, to be able to just run Garden deploy or Garden test, because tests are also a native element in how Garden works. So with Garden, you have a framework and a toolkit to reason about your whole system, deploy it all in a consistent manner, and kind of this speaks to the reproducibility aspect. I can deploy a full environment to debug in, to run my tests, and it's as production-like as you can get it, and way more so than say like running Docker Compose or some home-baked set of bash scripts that sort of make like a kind of a workable development environment. So and another key aspect with Garden is that especially in the context of Kubernetes, you can run Garden deploy, you can point it at a remote Kubernetes cluster, and it will feel as if you're working on a local environment. I think we'll use that to full effect here when kind of show Rookout in that context, and how the two of us can actually work together on troubleshooting an application. it's not always like, we do these kind of collaborative webinars, and they usually don't have this sort of cohesive feel to them. So I'm very pleased with this. And Garden. So just a little bit more about how Garden works. So it's an open source product, an open core. There is also an enterprise product that I'd be happy to separately tell you about. I'm not going to dwell on that for the context of the demo. But yeah, we can carry on. So I think it's best to probably show it in action. So what we are going to walk through here, I'm going to show how you set up your project with Garden, how you can easily spin up an environment, develop an environment for yourself. You can, and I'll show how that would work just the same for production deployments and for CI. Show how we can run tests, just run a suite of tests, integration tests, any other type of test from your laptop, and they're still actually running remotely as part of your environment. We will show what could have been just a production error and a user reported one. We'll show that in practice. So one of the things that we push a lot with Garden is high quality integration testing, which is traditionally very difficult to achieve, but Garden makes that somewhat easier, and we'll use that capability to surface a bug that be a little bit difficult to debug without something like Rookout. And then I'll quite organically hand it over to Oded to take it over, and we'll kind of show how that all flows together. But yeah, I think it's best to just dig in, show it in action. So let me get to the right screen here. So I guess it will pass me the screen share. There we go. Great. So we can see this. So what we have in front of us is a Garden dashboard. This comes with the open source product as well. What we're looking at is a quick overview of this example application that we're running. So it is a microservices application with several different components. We have API backend. We have, for the purposes of development, Postgres database and a Redis message queue. We have a couple of different UIs, which are these here. So the application is allowing me to vote between cats and dogs and looking at the results. It is vastly over-engineered for that single purpose, but that's kind of the point. We want to show, like, how a complex system becomes a little bit hard to debug, as well as hard to deploy and configure. So that's kind of a quick overview of all the components. Oh yeah, and there's also a background worker that processes the votes for no particularly good reason, except to show that we can. And then, so one of the things that's kind of most important about Garden is what we call the stack graph. The stack graph describes all the different components in your system and all the different steps involved in going from a bunch of source codes. In this case, it's all in one repository. It could be across many repositories, through builds, through deployments, any additional tasks that need to happen, like seeding a database, for example, and all the way down to tests, whether it's unit tests that have no runtime dependencies, to where it kind of gets interesting, integration tests and end-to-end tests that actually need like running instances of the rest of your stack. So let's take it to the terminal and bring this to life. So we have here, so I have this repository here. Kind of quickly, no, actually don't have that command. I'll show it in the IDE. So here's the repository structure. We have the services that I talked about. We have a backend API. We defined a project up top with a handful of different environments. We have a local one, a remote dev environment, and we also have a production environment, quote unquote. And we feed some variables, including our Rookout token here for the purposes of the demo. And then each component in the project has its own Garden configuration file. So let me quickly just deploy this into my test environment. So I'm gonna run Garden deploy. And this will basically walk through the entire repository. It will connect to the cluster, warn me that I need to do some updates, make sure everything's built. I just ran this command a little earlier. Might as well just do something like force, just to kind of actually have it do something. We'll basically walk through the stack graph, make sure everything's built, and then everything is deployed, all in one command. So you can see it in action here in the stack graph. And how all this is laid out. So one of the principles of Garden is that every part of your system should be able to describe itself. So here we have sort of a basic API server. It's really just like a one file Python application, couple of different routes. You can see here it's fetching the Rookout token, and it's initializing the Rookout SDK, which will come in handy later when things start to go wrong. And we basically do have one of these configurations for each of the services. Here we're having, so the API service is describing how it's built. That's basically, this is a container module, and that means we either fetch an image from a remote source or we build a Docker file next to it. We have a single service here, environment variables, ports, and health checks, etc. It's kind of, you kind of see this is a little bit like a hybrid between a Docker Compose level configuration and a Kubernetes one. And this gets at runtime converted to Kubernetes manifest. You can also provide your own Kubernetes manifest. You can provide Helm charts and several other things. In fact, like you can even you can use Garden to orchestrate Terraform deployments. You can deploy a Terraform stack and then get output from that, template into other modules. Lots of different things that I'm not going to focus so much on for this particular demo. But here's the interesting part, I think. So you can also define how this is tested. We have, let's say, a rather rudimentary unit test here that always will pass, but the interesting one is the integration test. So here we're actually running something in the namespace that I just deployed to. And for this test to work, it depends on the API service to be up and running. This also tells Garden, if I make a change, Garden can figure out which tests need to be rerun. So that's what I'm going to show in a moment. So let's first start by making sure everything works on our current branch. Just run Garden test. You can obviously also run individual tests, just kind of having Garden figure out what needs to be tested. Garden, well, not much at the moment, because Garden does cache test results. So if nothing has changed since I last ran it, or somebody else within the same environment has also run these tests at the particular source code and configuration versions, Garden doesn't need to do anything. But let's make it do something. Actually have it run those tests again. It will basically walk through the dependency graph once more. It will make sure everything's deployed in the right version, and then run these integration and unit tests that I have defined as part of the application. So here it's going through the API service, the result service, which is a web UI, also has something similar. I think, so here you can see, for example, an integration test that really is testing the whole end-to-end chain. And this is it needs the result service to be up and running, the API, the vote service, the worker, the whole kit and caboodle. So, and speaking of, so what is it exactly that's happening in this application? So when I go here, I hit cats, and then I look at, you can kind of barely see the line move there. Do it a little bit faster. And then you can see I'm incrementing this counter. I mentioned earlier, this is wildly over-architected. So it's probably best to explain a little bit like what's actually happening here. So when I poke this button, this vote service will ping the API backend, which will put the vote on a Redis message queue. The worker service here, a background worker, is listening on that message queue. And then once it gets the message, it will then persist the vote in the Postgres database. And the result service is basically polling for results for updated vote results from the Postgres database. And this is important to, like, usually I wouldn't even think to describe this as part of a demo, but this will come in handy when it comes to debugging with Rookout. Actually, I have already instrumented the application with Rookout. While Oded would dig into it a little bit more, notice that when I poke the button here, you can see this counter incrementing in the Rookout tab, which means Rookout and the breakpoints that I had set there are actually getting hit. So everything's working fine. Now let's see when it isn't working fine. I'm going to switch to a pre-borked version of this application, and I am going to test it again. Actually, let's just run the test and see what happens. So when I run Garden test here, it will not just run those tests. It will also make sure that the latest version is up to date. So let's see what's different between the branches. It needs to redeploy the API service. So that's clearly different from before. Once it's done that, it will deploy any other services that might also have changed. So the vote service is also affected. And then at the end, it will run any tests that are impacted by those changes. So kind of see here in the stack graph, finally arrives at this integration test here. And what I'm expecting to see is, well, it would be nice to get another green box here, but I kind of know that's not going to happen. Indeed. So what failed here, so we have an integration test that expects the vote counter to be incremented after the vote is processed. And so that appears not to be working. We don't get any more helpful information than that. It somehow isn't delivering. So maybe I can validate that quickly. Let's try voting for some dogs. Okay, it does seem to be doing its thing, but I wonder what's causing the test to fail. So I guess there's only we could go and, like, put in a bunch of console logs. I could look at the test code and or try and sort of kind of bend over backwards to try and somehow attach a debugger to a process that's running in a remote Kubernetes cluster. But we all know that's not a delightful experience. So let's then hand it over back to Oded, because he can show us how actually we should debug this with a powerful tool like Rookout. Does that sound good?
Bring it on.
Anybody has more questions? Yeah. Okay. Cool. Yeah. How do I do that? Let's see. Here we go. Good to go.
Good to go. So as we've just seen, there is a bug somewhere, and I could be either the developer who owns this bug. I could be an SRE who was just assigned to an issue that was reported somewhere about dog votes not being counted or cat votes not being counted, which is something we take very seriously at Rookout. And this is where Rookout comes in. Rookout is a live debugger. You can see, and this is on purpose, it looks and feels like an IDE. I can see the source code. I can see the application, the Python part of the application, the workers in Java, and the application servers in JavaScript. I can see the code, which I preloaded in advance. And one of really my favorite challenges as an engineer is to try and debug someone else's code. Happily, Rookout is something that lets me do that. And when I try to debug someone else's code and I really have no idea where I should start, I found a suspicious function that's all about voting, and I'm going to throw some breakpoints around, which if I was debugging locally with a classic debugger, this would have been me trying to run the process and see where it stops. Since we're in a live debugger, we cannot afford to stop. And also, since we're in a live debugger, we are already instrumented in the code, as Jon has mentioned. So the Rookout SDK has already been deployed in the application. It's a one-time change of adding the Rookout token as an environment variable or as a parameter in the code itself. And once that's done, I have access to every application that is instrumented with Rookout. So I have the application servers and the workers already connected. And if I had the same application running in multiple environments, for example, here everything is in dev, but if I had a version of this application in a test environment and another in a customer production environment, I would also be able to filter and pick those specific servers. Let me zoom in on the Python application server. I can see that the breakpoints are now full circles, which means that they are instrumented and ready to fetch data for us. And now, when we trigger the application again, we expect to see some data streaming in. Note that the application did not stop. We can keep voting, we can keep viewing the results, but every time this line of code is hit, Rookout instantly fetches all of the local variables, streams them to the Rookout user interface, and lets the application continue. So you have the benefit of seeing the data in the code level without having to stop your code, which is something you have to be able to do when debugging a live application or when debugging a microservice application. We can see that the breakpoints are indeed being hit. We can see that line 52 was not hit, so we're in this portion of the if condition. And if we look at this debug snapshot, we can see some data being pushed into a queue. We have all of the local variables. We have full visibility into the code, the variable names, their values, the collections, everything I need to know. I can also see some meta information about the environment in which they are running. I can see the stack trace, and I can actually set breakpoints up the stack, which is another very, very helpful debugging practice. And what we're going to look for here is any information about the voter ID, which is the usual suspect. I can see some data being passed around here, but I'm not sure if this is the way a voter ID should be formatted. So I'm going to switch over to the worker. And I'm going to take these breakpoints off. And I'm going to look at the worker application, which has also been instrumented. And again, I'm going to basically spray and pray. I'm going to see if I get into the try condition, into the catch condition. And once the breakpoints are active, I'm going to trigger the app again. And just make sure I'm triggering the right flow. We have some data. Here we go. We've entered, and we have a breakpoint hit in the catch, which usually means that something went wrong. Somewhere I have the full exception details, and I can see what the problem is. Jon, this should be a hint for you as the developer who wrote this, so I can instantly open a bug ticket or open a support ticket with all the information you need in order to troubleshoot.
Indeed. So if I now go, it's a classic camel case versus snake case failure. It's what you run the risk of in microservices that don't share each other's types and schemas, and Python doesn't have them to begin with. So, but that's easy. Just go and fix, run Garden test again. Just takes just a short while, and hopefully we will soon see something hitting the other breakpoints. What we want, looking at the code here, is for it to reach the update vote function method there, and then it should be inserting into the database. So now it's can't see my screen, but it's redeploying the vote service. It's already redeployed the API service, and now it's about to run the integration test that failed earlier.
Okay, we have liftoff. We have data, and it is outside the catch section. And we have data from inserting into the database. And it looks like the issue has been solved, and it has been solved using the same environment without having to ship it again, without having to add log lines and wait for them to be printed. In literally a matter of minutes, we were able to replicate the problem, find the root cause, ship a new version, and validate that the ship indeed fixed the problem.
It's a pretty powerful combo. So using Garden, I'm actually deploying. So all the builds and deploys happen remotely in the Kubernetes cluster. So it's something that we can easily share. You could open the UIs, and we could bounce around in the same environment. Rookout also makes that very easy. I have my own instance running as well, and you have yours. So the collaborative aspect of this is also something that really impressed me during this discovery process. Yeah, I'm very much looking forward to having all this set up for all our internal development as well. And I think it's been really slick.
That's such good news for a product manager to hear. And of course, we have not prepared this part of the session. So just a quick recap before we open it up to some question. We've seen Garden used to spin up a test environment and run some tests, and we ran into a test failure, but the log from the error log from the test would not tell us what went wrong. We used Rookout to get to the root cause without stopping the application and without shipping it again, without adding log lines. Once we found the root cause, we were able to quickly fix it, deploy, and run the test again. And we know that no matter how thoroughly you test, customers are going to test it all over again and find a new bug. So we were able to also test in the live environment and make sure that the bug was indeed fixed, which is a real time saver and a problem solver when you're trying to solve live applications in a very complex Kubernetes environment. So I think this would be a good time to stop for questions from the audience.
Okay, perfect. So we actually have a couple of questions here. Jon, we'll start with you. You mentioned using Garden and CI. Is Garden a CI tool?
Well, it's unique in that it is a hybrid between a development tool and a CI/CD automation tool. So the benefit there is you can run Garden from any CI system and use the exact same configuration that I was just using for my like inner loop development and rapid iteration. So I guess we didn't really touch on that in the demo, but typically we have a dev environment configured in the project, and then we have a separate CI environment. And I, as a developer, can run garden --env equals CI, or basically reduce my CI pipeline, whether it's being run through whichever CI/CD system, Jenkins, Circle CI, BuildKite is pretty popular. Any CI/CD system can just run garden test, garden deploy, garden test, much the same as I can do as a developer. So yes, and more, I guess is the TLDR.
Okay, awesome. Okay, Oded, this one's for you. What is the performance impact of Rookout?
You always get that question. And you always get it because usually when we show Rookout, we first and foremost speak about production debugging. And when you worry about deploying an app in production, you worry about a performance hit. We test Rookout thoroughly, and we instrument it in a very safe way, and we make sure that the CPU and memory impact are less than 1%. The actual behavior of what Rookout does behind the scenes is causing your code to run as if it was just printing yet another log line. We instantly basically add the log line into your code, and when the breakpoint is taken off, we stop printing the log line. So you can think about it as printing another log line into your code. We just save you the hassle of adding the code, pushing the change, going through the test, and waiting for it to be collected. So the performance impact should be negligible.
Awesome. Okay, Ion, for you, I'm just going to ping pong here, guys. Can Garden only be used with Kubernetes?
It's most commonly used with Kubernetes. So Garden is designed to be pluggable, and Kubernetes is by far the bulkiest and most maintained plugin out of all the plugins for Garden. But we do have, we have customers who are not using the Kubernetes plugin, and really only using the Terraform and kind of more traditional like shell execution modes, using it to kind of tame the complexity and kind of put it all in a dependency graph. So it's like the bulk of our audience is really Kubernetes at the moment, but we're very much looking forward to supporting more platforms over time beyond Kubernetes and Terraform, which are the most popular ones today. We're always looking for people to ask us politely to support something else, looking for coming trends in serverless, for example, because we really don't want, like, if you've gone through all this trouble retooling to get set up for Kubernetes, and then Kubernetes falls out of style in however many years. It's inevitable. It's just a question of when. We wouldn't want you to have to rewire your whole dev tooling, CI, everything. So it's designed to support more, but realistically, mostly we're catering to Kubernetes users today.
Okay, cool. Well, I hope that happens for you in the future. Oded, for you, do you support on-prem deployment?
Yes, a loud and clear yes. Rookout is, well, the most obvious usage for it is cloud native applications, where it's hard to instrument and it's hard to reach the servers. We do have a bunch of customers using Rookout mainly to debug on-premise applications. We have an agent you can deploy locally. We have a bunch of security mechanisms to make sure that your data stays local as well. And as long as you have an outbound communication for HTTPS, just so that we can monitor and make sure that nothing is broken, Rookout can be deployed for debugging on-prem applications.
Nice. Okay. Jon, last one for you, and then we have a last one for Oded after. Can Garden be used to deploy to production?
Yeah, I think it's not where we started with our focus, but more and more of our users are doing just that. I think there are other tools that kind of in the realm of like GitOps and things like that do more with respect to gradual rollouts and canary rollouts and things like that. But in reality, most people aren't doing that in any sort of a meaningful way. It's something that we all aspire to be doing, but realistically, most of us are really just running Helm install and kubectl apply when deploying to Kubernetes. And compared to that, Garden is actually way better because it does things in dependency order. It has it's the way we do versioning and status checks. We can be smart about what needs to be deployed and when. So yeah, more and more of our users are deploying to production, and that kind of captures the full benefit of having just one configuration that runs across everything. You just kind of template in different, you have more replicas for this environment. In this environment, I use Terraform to deploy like a proper like RDS or Postgres instance that isn't like a container in a Kubernetes cluster. But for development, you need something simple. So Garden allows you to encapsulate that all very neatly, and yeah, we use it for our own production deployments. Obviously, we would, but a lot of our customers also do.
Very cool. Okay. And then the last question, Oded, what's necessary to onboard Rookout?
So I think Jon touched on it. The Rookout deployment is quite straightforward. It's a Java agent or a Python package or an NPM package or a .NET NuGet. It's basically one line of code being added to your application, just invoking the Rookout package and passing on the Rookout token as a parameter, and that's it. The installation is usually quite straightforward.
I can vouch for that. Yeah.
Amazing. Yes, so those are all the questions we have.
Great. So yeah, I guess that's us wrapping up. So yeah, that's how you contact me. That one, yeah. So we have our website, obviously. If you want to learn more about what Garden is, what Garden does, that's my Twitter handle right below there. That's Garden's Twitter handle below that. And lastly, like feel free to send me an email if you find this interesting and want to see more of a complete demo. Glossed over a lot of things here, but you got to keep it focused. Yeah. Thank you so much for having me. It's been a delight.
Yeah, it's been a real pleasure preparing this. I think solving the same problem from both directions is really a pleasurable things to show. So thank you for joining us, and thanks for hosting us and helping us prepare for this session.
Yeah. And thanks everyone for being here. And we'll send you the recording as well. So keep your eyes peeled for that in your inbox. And have a great day, a great night, everyone, wherever you're located in the world.
Thanks, everyone.
Bye, everyone. Take care.